Hey everyone. We took last week off to build something optimistic and beautiful on Royal Road. It's absolutely free, so go check it out. The link is in the description.
Yeah, we're really excited to finally share it with you.
But right now, before you click away or, do anything else, I want you to just take a second and imagine something for me.
Okay.
Imagine waking up tomorrow to a world where artificial intelligence isn't just sitting there in a browser tab, passively waiting for your prompt, but it is actively, autonomously rewriting its own underlying source code while you sleep.
Right. Which is wild to even conceptualize.
Totally wild. And imagine a world where your neighbor is, popping a new over-the-counter pill to function flawlessly on 4 hours of sleep, and humanity as a whole is preparing to literally beam thoughts brain to brain.
Like straight out of a comic book.
Exactly, like a ridiculous science fiction movie pitch. But this is the reality we are unpacking today.
It really is. I mean, it's entirely real, it's documented, and it's happening right now in laboratories and corporate headquarters around the world.
Today's show is an inspiring celebration of impossible ideas and the minds brave enough to chase them down. Finding passengers bold enough to embark on our good ship's journey is harder than most people think. So drop a very humane thumbs up right now to send a signal flare to drifting knowledge pirates like yourself. We know they're out there. Let's bring them home. We're keeping it lighthearted, as usual, but we promise to never skimp on the intelligence. Now let's kick off this voyage with today's new revelations.
Yeah, so the compass we are using to navigate this voyage is this highly concentrated intelligence dispatch. It was written by Dr. Alex Wissner-Gross,
Okay.
and it is titled The Innermost Loop, published on June 25, 2026. So our mission for this deep dive is to synthesize what is really a monumental paradigm-breaking shift.
Right.
We are looking at how the singularity, that concept that used to be a purely theoretical moment.
Yeah, like late-night dorm room debate material.
Yeah, exactly. When technological growth becomes uncontrollable, well, it's no longer a future concept. It is touching everything right now. We're going to track this from the fundamental silicon in our devices all the way up through human biology into outer space, and finally down into the legal rights of literal trees in the ground.
Okay, let's unpack this right from the start.
Yeah.
Because to understand any of the biology or, the space travel stuff, we have to start at the absolute core of this 2026 reality.
We really do.
We are officially in an era where AI is no longer a passive tool. I mean, for years, we just thought of it as a highly advanced calculator. You hit equals, and it spits out an answer. But the dispatch explicitly states that the Singularity has begun editing its own source code.
Which is the ultimate threshold moment in computer science. What Dr. Wissner-Gross is highlighting here is a breakthrough into what is called the self-harness paradigm.
The self-harness paradigm.
Right. And to understand how massive this is, just think about how software has been built for, the last 70 years?
Human hands on keyboards.
Exactly. If an AI system had a weakness, say it hallucinated facts about history, or just couldn't solve a specific type of logic puzzle, a team of human engineers had to go in. They had to diagnose the problem, write new scaffolding, test the code, and finally deploy a patch.
It was a very manual, iterative process.
Highly manual. But now, an agent can autonomously mine its own outputs for weaknesses. It writes its own scaffolding. And according to the dispatch, this closed-loop process is lifting terminal bench scores by double digits.
By itself.
Entirely without human intervention.
So for those of you listening who might not, spend your weekends reading dense AI research papers, a terminal bench score is essentially a benchmark that tests how well an AI agent can operate a computer terminal.
Right, using the command line.
Yeah, using the command line and resolving coding errors on its own. So a double-digit leap without human help is mind-blowing. It's like imagine a race car.
Okay, a race car.
You've got this high-performance machine tearing down the track at 200 miles per hour. But instead of needing to pull into the pit stop so a human crew can, change the tires and tweak the engine,
Right.
the car is actively upgrading its own engine and swapping its own tires while it's still driving at top speed. It completely eliminates the need for the pit crew.
That's a great way to visualize it. But I'd say it's even more extreme than that. Because a race car is still constrained by the laws of physics and its initial chassis, right?
Sure.
A better way to think of this self-harness paradigm is a race car that is driving down the track and suddenly realizes it would be faster if it were an airplane.
Oh, wow.
So while driving, it just melts down its own chassis, reforms its metal into wings, and takes off. We're talking about fundamental structural changes to the way the model processes logic. And it's all initiated by the model itself.
That is insane to think about.
It is, because for years we treated AI primarily as a knowledge retrieval system. You ask a question, it fetches or generates an answer based on a static set of training weights. But this self-harness paradigm, it represents a definitive shift to an action-oriented agent.
So it's no longer just thinking.
Exactly, it is doing.
And if the machine is thinking that fast and acting that autonomously, I mean, the way we talk to it has to change, right?
Oh, absolutely.
Typing on a keyboard to communicate with an entity that can rewrite its own code in milliseconds. It feels like communicating through a telegraph.
Yeah, it's way too slow. The input method has to evolve, and we are seeing that breakneck evolution right now. The dispatch highlights OpenAI's Greg Brockman previewing true bidirectional voice.
Walk me through what bidirectional actually means in this context, because, I mean, we've had voice assistants on our phones for a decade now.
Right, but those old voice assistants were strictly turn-based. You speak, the system records your audio, sends it to a server, transcribes it to text.
Processes a response.
Yeah, turns that text back into audio and plays it for you. There is inherent latency. It's clunky. Bidirectional means the AI is processing your audio input while it is speaking to you.
So it's not waiting for you to finish.
Not at all. If you interrupt it, it dynamically adjusts its sentence midstream, just like a human would in a natural conversation. It's a fluid overlapping exchange. And coupled with that, the dispatch notes they've shipped GPT 5.5 Instant, which is explicitly described as warmer.
Warmer.
Yeah, warmer and drastically better at reading user intent.
Right, so it's moving from a purely transactional relationship, like set a timer for 10 minutes, to a relational one, where it's interpreting your tone of voice, maybe your hesitation.
Exactly.
But it's not just talking. Google is baking actual computer use into Gemini 3.5 Flash, so the agent can perceive your screen and actually click on things.
Yes.
Perception is fusing directly with action.
And that is the critical bridge from the digital abstract into our practical daily lives. When an AI can perceive a digital environment just like you do.
Seeing the desktop icons, that kind of thing.
Yeah. Seeing the icons, reading the layout of a really complex spreadsheet, understanding the visual hierarchy of a web page, and then taking action by moving a cursor and typing, the entire digital world just becomes its sandbox. It's no longer confined to a little chat box on a website.
I really think people underestimate how hard that is. For an AI to know the difference between, say, a decorative image of a button and an actual functional button on a poorly designed website.
Whoa, it requires immense contextual awareness.
It's huge. And it's not just clicking, it's creating too. The dispatch mentions Crea2 open sourcing SODA text to image. And just to clarify for the audience, SODA stands for state of the art. So the absolute cutting edge of visual generation is just being handed out to the open source community.
Right, and seamless visual generation combined with screen manipulation. It means these agents can generate, perceive, and manipulate visual data instantly. And, the economics of the tech industry are violently shifting to match this new reality.
Also.
Well, Dr. Wissner-Gross notes that new Claude code strings are hinting that Fable 5 is returning to a subscription model.
Which honestly makes total sense. I mean, if you have an autonomous agent that is constantly running in the background, reading your screen, listening to your microphone, and rewriting its own code to serve you better, you can't just charge per query anymore.
Exactly. It's a continuous service.
But wait. If these agents are running continuously, constantly thinking and seeing, the amount of computing power that requires is terrifying to even think about.
And that is exactly where the bottleneck lies. A self-improving digital brain requires an unfathomable physical infrastructure to support it.
The hardware.
Yes. This autonomous software revolution is colliding headfirst with the physical limitations of our planet. We are talking about silicon, power grids, and the raw materials that are rapidly becoming the new oil.
The numbers in this dispatch regarding the physical hardware are just staggering. I mean, let's talk about the chip wars for a second. Japan's Prime Minister Takaichi just unveiled a $2.3 trillion plan to quintuple their chip output.
It's massive.
Trillion, with a T. That is a number so large it basically loses all meaning. And it pushed the Nikkei stock index past 72,000. Why is Japan, a country that has historically been very, calculated with its national spending, throwing $2.3 trillion at silicon?
Because they recognize that in the 2026 economy, compute is the new global currency, period.
Wow.
Nations aren't just investing in tech to have the coolest consumer gadgets anymore. They are militarizing their economies around silicon production because it directly dictates national security. And the dispatch highlights memory specifically as a massive bottleneck.
Memory, right.
Yeah. Micron has become the technology sector's margin king. They are sitting at a record 84.9% profit margin.
An 85% margin on a physical hardware product is almost unheard of in manufacturing. It's absurd.
It really is. They hit $1 trillion market cap because global data growth has multiplied by 7 times in a very short window. And there's a fascinating metric in Dr. Wissner-Gross's notes that perfectly explains why this is happening. A humanoid robot requires 10 times the memory of a self-driving car.
Okay, stop right there, because that stat blew my mind when I read it.
It's crazy, right?
It is. A self-driving car is already processing a ridiculous amount of visual data. It has LiDAR, radar, 8 cameras shooting in 4K. It's tracking pedestrians, other cars, weather conditions. Why on earth does a robot walking around my house need 10 times the memory of a 2-ton vehicle navigating highway traffic?
It really comes down to the difference between structured and unstructured environments. A car, despite all the variables of traffic and weather, navigates a highly structured world.
Okay.
It has paved roads, painted lanes, traffic lights with universally agreed-upon rules, and very predictable physical constraints. Plus, a car only moves on a 2-dimensional plane, forward, backward, left, right.
Okay, that makes sense. A road is basically just a giant, well-lit track.
Exactly. Now put a humanoid robot in a kitchen. The environment is pure chaos. It has to navigate stairs, which introduces complex verticality and gravity calculations. It has to open doors with varying handle types and spring tension. It has to interact with soft objects. I mean, knowing the difference in grip strength required to hold a paper cup of hot coffee versus a heavy cardboard box.
Oh, that's a lot of micro adjustment.
Constantly. It has to dynamically balance on 2 legs while reaching for something on a top shelf. The spatial awareness, the real-time physics calculations, and the object recognition libraries required for delicate manipulation in unstructured human environments, they just demand an astronomical amount of active short-term memory.
So to process all that memory, to do all that thinking, we are seeing massive shifts in inference chips. And just a quick primer for you listening, when we talk about AI hardware, there's training, which takes months in supercomputers to teach the model how to think.
Right.
And then there's inference, which is the actual thinking the AI does when you ask it a question in real time. So the dispatch notes that Qualcomm bought a company called Modular to challenge CUDA, and they unveiled their new Dragonfly C1000 CPU, getting Meta as their first customer. Why is Modular such a big deal here?
Because of CUDA. CUDA is NVIDIA's proprietary software platform that allows developers to write code for NVIDIA's GPUs. And over the last 15 years, almost every single AI researcher learned to write in CUDA.
So they were locked in.
Completely locked in. It created a massive software moat. Even if a competitor built a faster chip, nobody could use it because all the existing AI code was written specifically for NVIDIA's ecosystem. Modular is a software platform designed to crack that moat. It allows code to run efficiently on non-NVIDIA hardware.
It's the ultimate escape hatch from a monopoly. And everyone is racing for the exit, it seems. OpenAI and Broadcom just taped out their first custom inference chip, codenamed Jalapeno, in just 9 months. I hear the phrase taped out all the time in tech news, but I've never actually known what it physically entails.
Yeah, taping out is actually a legacy term from the early days of electronics, back when circuit board designs were literally laid out using black tape on Mylar film.
Oh, literally taped.
Literally taped. Today, it just means the final design phase of a microchip is complete, and the digital blueprints are sent off to the foundry like TSMC in Taiwan to be physically manufactured using photolithography.
So hitting tape out in 9 months?
9 months from concept to tape out in the semiconductor industry is breakneck. It is almost reckless speed.
Really?
Oh yeah, it usually takes years. It shows a desperate existential need from companies like OpenAI to secure their own hardware destiny. And this desperation is leading to intense geopolitical hardening. The European Union just signed the US-led Pax Silica Pact against China.
Pax Silica. The piece of silicon. It sounds like a treaty from a dystopian novel.
It essentially acts as one. As part of this pact, the EU agreed to buy $40 billion in U.S. chips, completely cutting out competing nations from their critical infrastructure. But here is the massive physical reality we keep dancing around. You can print all the inference chips you want, you can break NVIDIA's monopoly, But you still have to plug these servers into a wall.
Yes, and this is where the story gets really visceral for me. Powering all of this. The energy demands of the Singularity are literally reshaping the global power grid. The dispatch notes that Sunrun, Tesla, and Renew Home are stitching together home batteries and electric vehicles to create 16 gigawatts of flexible capacity.
Think about the scale of that. 16 gigawatts is roughly the equivalent of 16 nuclear power plants.
And it's not coming from a centralized plant. That means the cars sitting in our driveways and the batteries bolted to our garage walls are being aggregated by software to act as a decentralized power plant to feed this beast. When the grid gets strained by AI data centers, they siphon power from your car.
It's a complete inversion of how power grids have operated for a century. And the corporate players are taking extreme measures, too. Dr. Wissner-Gross notes that Walmart just signed its first nuclear deal.
Walmart, a grocery store chain. A place where I buy my socks and cereal is buying nuclear power.
Because Walmart runs one of the most complex supply chain algorithms on the planet, and they realize they cannot rely on municipal grids to power the AI required to maintain their logistics edge. Furthermore, the dispatch mentions NVIDIA backing EcoWave Power, which is a project designed to run data centers entirely on the kinetic energy of ocean swells.
We are literally terraforming our own planet, tapping into the rhythm of the ocean and splitting atoms just to give these machines enough juice to think. Which brings me to a realization that I need you to validate, because it sounds kind of crazy.
Read on me.
The dispatch mentions that compute itself is becoming a tradable commodity. Andreessen Horowitz, the massive venture capital firm, funded a company called Orn to offer the first modern exchange for compute as a commodity. Are we looking at a future where access to AI processing power dictates personal wealth? Like instead of a gold standard or the petrodollar, we have a compute standard.
That is precisely the trajectory, and it is perhaps the most profound economic insight of this decade.
Really?
Think about it. If compute is what drives automation, problem-solving, intellectual property creation, and raw economic output, then teraflops become as foundational as acres of arable land in the agrarian age, or barrels of oil in the industrial age.
So wait, in the 19th century, wealth was land. In the 20th century, it was oil. You're saying in this decade, personal wealth will literally be measured in your ability to access or own processing power. How does an average person even participate in that economy?
They might not, which is the terrifying part of the transition. It could become highly centralized, but we're already seeing the trickle-down effects of this energy compute nexus translating directly into physical goods.
Like what?
The dispatch mentions a company called Slate Auto, which is backed by Jeff Bezos. They just opened orders for a $24,950 pickup truck. In an era of massive inflation, they are explicitly attributing this shockingly low price to cheap electrons.
Because they've automated the manufacturing and optimized the supply chain so thoroughly with cheap AI compute, they can build a truck for half the price of legacy automakers.
Exactly. The AI revolution is fundamentally an infrastructure and energy revolution.
So if we just take a breath here, we have these autonomous brains rewriting their own code. We have a global scramble to build the silicon to house them, and we are tapping into nuclear and tidal power to feed them. But that leads us to the messy, complicated, deeply human part of the equation.
It always comes back to us.
Right. We're building these massive nuclear-powered data centers just to give these agents enough juice to think. But that raw computing power doesn't mean anything if we can't trust the decisions they're making. Who actually controls the behavior, the identity, and the underlying morality of these systems?
This is what many in the field are calling the battle for the machine's soul. As these models gain autonomy and near-infinite compute, the culture, bias, and identity instilled in the AI become absolutely paramount.
The corporate pivots happening in response to this pressure are fascinating. For instance, the dispatch notes that XAI is leaning heavily into video and image generation now. And the stated reason is mostly because Grok's text traffic proved to be a bit too racy or unfiltered for mainstream advertisers and enterprise users.
Right.
They built an unfiltered AI, and it turns out capitalism prefers a filter.
Mm-hmm.
Meanwhile, Meta is quietly coding a prediction market app where their llama model writes and settles bets live.
And a prediction market settled autonomously by an AI is a massive philosophical step.
So,
Well, a prediction market is essentially a platform where people place financial bets on future events. Who will win an election, what the temperature will be in a specific city, will a certain company miss its earnings. To have an AI settle those bets means we are trusting the model to be an objective arbiter of reality.
it has to decide what is true.
Yes, it has to look at real-world events, determine the outcome without bias or hallucination, and distribute human funds accordingly.
Which makes the issue of bias incredibly sensitive. And I want to pause here and be super clear with you, the listener, right now. We are strictly delivering the findings of the audit mentioned in Dr. Wissner-Gross's source material. We are not endorsing any political viewpoint, we are not taking sides, and we are not making a commentary on who is right or wrong here. We are simply imparting the data of what these models output when audited.
And it is crucial to remain impartial here because the data itself is full of fascinating contradictions. The Dispatch cites a recent comprehensive audit of these major frontier models.
What did they find?
The audit found that ChatGPT, despite OpenAI's efforts at neutrality, consistently leaned left in its responses to politically charged prompts.
Okay.
Google's Gemini was actually found to be the most strictly neutral of the group. But the most interesting finding, given its stated positioning as the anti-woke or unfiltered alternative, was that xAI's Grok was actually found to cite left-leaning viewpoints more often than not.
Wow. It just shows how incredibly difficult, maybe even impossible it is to engineer perfect objectivity when the training data is just a mirror of human history and the messy, biased internet. If you train a model on human text, you get human contradictions. And because we can't fully trust the output of these synthetic minds yet, trust itself is becoming a piece of hard infrastructure.
This is one of the most profound shifts in our daily digital lives. We are moving from an internet of assumed humanity to an internet of assumed synthesis.
Assumed synthesis.
Yes. The Dispatch highlights that Cloudflare and major web browsers are rolling out what they call personhood tokens. The internet is now so flooded with autonomous agents, some helpful, many malicious, that platforms need a cryptographic way to sort actual human beings and authorize bots from the digital noise.
Imagine opening your laptop tomorrow morning, and before you even type your password, your browser demands a cryptographic token just to prove you have a heartbeat. That's the internet we're moving toward. But how does that actually work? How does my browser know I'm human without me, uploading a DNA swab or destroying my privacy?
It relies on advanced cryptography, specifically zero-knowledge proofs and hardware attestation.
Okay, unpack that.
So modern devices have secure hardware enclaves, like the chip that stores your fingerprint or Face ID on your phone. When you unlock your device using biometrics, the hardware enclave generates a cryptographic token that essentially says, I verify this is a human user.
Right.
This token is passed to the website using a zero-knowledge proof, which allows the website to verify the token is authentic without ever seeing your actual personal data or biometric information.
We used to just click a box that said, I am not a robot, and select the traffic lights in a grid. Now our very personhood has to be tokenized and cryptographically verified just to read a news article. It implies that the default assumption of the internet is no longer human.
Exactly. The baseline is synthetic. You have to provide a passport to prove you are biological. And the stakes for controlling these synthetic minds are so high that it is leading to massive corporate espionage.
The scale of this espionage is crazy. The Dispatch notes that Anthropic publicly accused Alibaba's model, Quinn, of a massive distillation attack. We're talking 28.8 million harvested exchanges. To put that in perspective for you listening, imagine a classroom where you have one absolute genius student. A distillation attack is like another student secretly copying the genius's answers to millions of practice questions, learning the patterns of how the genius thinks, and then claiming they mastered the subject themselves. They didn't do the hard work of learning the foundational knowledge, they just strip mine the output.
That analogy captures the theft, but the reality is actually much more insidious. It's not just copying the answers. It's algorithmically reverse engineering the genius student's brain structure so you can build a cheaper, localized clone of them.
Oh, that's hard.
A distillation attack involves taking a massive, highly capable model like Anthropic's Claude and using it to generate millions of high-quality responses. You then use those responses to train a much smaller, cheaper model.
So the small model learns to fake it.
The small model learns to mimic the big model's reasoning without requiring the billions of dollars in initial training compute.
So it completely collapses the competitive moat of the frontier labs. If an open source or foreign rival model can just algorithmically mimic your multi-billion-dollar model for a fraction of the cost. The economics of AI development implode. Why spend 10 billion training GPT-6 if someone is just going to distill it for 100 grand?
Precisely. This is why the culture inside these labs is so intense, and why they view their work not just as software engineering, but as global statecraft. The dispatch notes a fascinating trend. Frontier labs are now hiring actual philosophers to write AI constitutions.
They aren't just coding algorithms anymore. They are literally legislating morality in Python.
And the talent wars to secure the people building these systems are vicious. Anthropic just poached 2 more key staffers from Google's Gemini team. Furthermore, Anthropic's envoy, Tom Brown, reportedly charmed the White House, conducting high-level meetings that smoothed over relationships after the administration had apparently been cool on Anthropic CEO Dario Amodei.
It's high-stakes diplomacy. But instead of negotiating over nuclear weapons or trade tariffs, they are negotiating over AI alignment and the behavioral bounds of superintelligence. Because once that intelligence is secured, aligned, and regulated in the cloud, it doesn't just stay in the digital realm.
No, it does not. Once an autonomous agent has access to tools and immense compute, it turns its analytical gaze onto the physical world. Specifically, onto the most complex codes in existence, human biology and quantum physics.
And this is where the dispatch goes from fascinating to absolutely reality-breaking. We are looking at an era where AI is solving the wetware. Let's start with high physics, because this point genuinely gave me pause.
Yeah, this is a big one.
Ed Witten, who is widely considered one of the most brilliant theoretical physicists alive today, the guy who helped pioneer string theory, credited Claude Opus 4.8 for generalizing an entanglement wedge calculation.
We really need to dwell on this because it represents a phase transition in human discovery.
Wait, walk me through what an entanglement wedge even is. Are we saying the AI is acting as a fancy calculator for a physicist? Or is the AI literally doing the theoretical physics itself?
It is doing the theoretical physics itself.
You're kidding.
I'm not. In quantum gravity and holographic duality, an entanglement wedge is a highly complex geometric concept that relates the boundary of a space to its interior holographic region.
Okay.
It is math so abstract and multidimensional that only a handful of humans on Earth can properly visualize and manipulate it. Ed Witten didn't ask Claude to do arithmetic. He used the AI to generalize a calculation across this theoretical framework. The AI understood the complex physics concepts, navigated the abstract mathematics, and produced a generalized solution that advanced a theoretical physics paper.
An AI, trained on human language, is doing end-to-end theoretical quantum physics research at the level of Ed Witten. That alone should be front-page news globally. But the dispatch moves right along to biology. That same analytical power is industrializing the life sciences. NVIDIA just launched the BioNeMo Agent Toolkit.
The BioNeMo toolkit is revolutionary because of how it bridges the gap between raw compute and biological application. It turns complex biomolecular models into callable skills for an AI agent, and they boast a 100% completion rate.
I want to make sure I understand that practically. It means a biological researcher doesn't need to know how to code complex physics simulations. They can just prompt the AI in plain English to run a biomolecular simulation on how a certain protein folds, and the AI handles all the messy middle steps perfectly.
Exactly. It removes the friction from biological discovery. In the past, if you wanted to simulate a protein, you needed a team of computational biologists to write custom scripts, manage server loads, and interpret the data. Now, the AI agent treats simulate this protein the same way your phone treats turn on the flashlight.
It's just a button.
It is a callable skill, and the implications of this are compounding rapidly. The dispatch highlights a researcher from Stanford, Brian High, who unveiled something called Proto.
And Proto is described as a language that composes DNA, RNA, and proteins into validated designs.
Think about what that implies. We have mapped the human genome, but for decades, manipulating it was like trying to edit a book by randomly swapping letters and hoping it still made sense. Proto acts as a high-level programming language for biology.
Wait, slow down. You just said DNA is a programming language to these systems. Do you mean that metaphorically, like it's a useful way to think about it? Or are they actually compiling proteins the way a software engineer compiles Python code?
I mean it literally. It is no longer a metaphor. To an autonomous AI system with a BioNeMo toolkit, human biology is just another software program waiting to be debugged, refactored, and optimized.
That is wild.
Proto allows an AI to write a sequence of DNA to achieve a specific function, compile it, and validate that it will fold correctly in reality. BioIQ has even launched public leaderboards for life science and biosecurity, completely gamifying biological breakthroughs.
Gamifying it.
Yeah, teams are competing on leaderboards to design novel proteins the exact same way hackers compete to find software bugs.
Which leads us directly into upgrading the human machine itself. If biology is just code, it's time for an update. Elon Musk's Neuralink says they may attempt brain-to-brain telepathy through latent space this year. Just pause on that phrase. Brain-to-brain telepathy through latent space. We are talking about converting a human thought into digital data, passing it through an AI, and beaming it into another human's brain.
It is the ultimate circumvention of human language.
Explain the latent space part of that, because that sounds like magic.
Latent space is a concept in machine learning. Imagine a massive, multidimensional mathematical map where an AI stores concepts based on their relationships. Dog is near wolf and bark, but far away from submarine.
Right.
When an AI translates language, it maps a word into this space, finds the meaning, and pulls out the corresponding word in another language. What Neuralink is proposing is bypassing the words entirely.
So instead of me having a complex feeling, struggling to compress it into the clumsy English language, using my vocal cords to vibrate the air, and hoping your ears receive it and your brain decompresses it correctly.
Exactly. Language is a tragically low bandwidth communication tool. Telepathy, through latent space, aims to read the raw neurological firing of your concept, map it to the AI's multidimensional latent space to understand the pure meaning, and then stimulate the corresponding neurons in the receiving person's brain. It transfers the uncompressed concept directly.
That is both awe-inspiring and deeply terrifying. To have another person's raw thought injected into your consciousness, the psychological implications are staggering. But if telepathy is the big, flashy sci-fi upgrade, the pharmaceutical industry is chasing subtler biological hacks that might fundamentally alter society much faster.
Yes, the pharmacology aspect is moving incredibly fast.
The dispatch notes that Eli Lilly closed its acquisition of a company called Centessa, and the market is betting heavily that they are sitting on an orexin agonist. The dispatch casually mentions this is a pill that could let anyone feel perfectly rested on just 4 hours of sleep.
To understand the magnitude of this, we need to look at the biology. Orexin is a vital neuropeptide in the brain that regulates arousal, wakefulness, and appetite. People with narcolepsy, for example, often lack orexin.
Okay.
And an agonist is a chemical that binds to a receptor and activates it.
So how is this different from just drinking a massive amount of caffeine or taking a stimulant?
Caffeine just blocks the receptors in your brain that tell you you're tired. It masks the fatigue, but the biological debt is still accumulating. A powerful orexin agonist would bind directly to the wakefulness receptors and turn them on at a fundamental level. It effectively hacks the brain's sleep-wake cycle.
So you aren't just ignoring the fatigue.
Right. It wouldn't just keep you awake, it would trick your brain into functioning optimally, feeling completely restored, while drastically reducing the time spent in the sleep state.
Okay, I have to push back on the societal implications of this. Because my immediate thought isn't, wow, I'll have so much more time to paint and read. My thought is, if everyone can function flawlessly on 4 hours of sleep, doesn't that just mean corporate culture will adapt to expect it?
Oh, almost certainly.
Are we just bioengineering ourselves to be better cogs in the economic machine? If a bank knows its analysts only need 4 hours of sleep to not die, they will absolutely demand 20-hour workdays.
That is the perennial danger of biological optimization under hypercapitalism. If the biological limit of the 8-hour sleep cycle is removed, the economic baseline immediately shifts. The competitive advantage of sleeping less disappears when everyone can do it, and it just becomes the new mandatory minimum.
That's grim.
It becomes a profound question of whether we use that unlocked time for human flourishing, or if it is immediately absorbed by corporate productivity demands.
It's a terrifying thought. But it's not all dystopian corporate grinding. The AI intervention in our biology is also scaling prevention in incredible ways. The dispatch mentions that Stripe, Anthropic, and OpenAI are collectively backing a project called Intercept. This is a massive $500 million push to eradicate respiratory viruses globally.
And we are seeing individual interventions scale as well. The dispatch cites a system called EchoNext, which is an AI-powered ECG.
Yeah.
It successfully caught a hidden asymptomatic heart disease in a patient purely by analyzing subtle data patterns that human doctor would never notice. And it instantly triggered a life-saving transplant process.
Even the notoriously slow regulatory agencies are getting out of the way. The FDA just dropped its complaint against Whoop's blood pressure tracking feature.
What we are witnessing is the rapid transition of healthcare from a reactive human bottleneck system to a proactive AI-scaled system.
So?
Well, in the old model, you wait until you feel sick, go to a doctor, they run tests, and they try to fix the damage. When continuous algorithms monitor your biological data 24/7, disease becomes an anomaly to be flagged and patched in real time, much like a cybersecurity system isolates a virus before it crashes a network.
So we are curing viruses, hacking sleep, and mapping thoughts.
Hmm.
But if we are re-engineering the human body and our internal biology so thoroughly, it naturally extends to re-engineering our physical environment. We are moving from the wetware to the hardscape. The machines are stepping off the assembly line and into our daily lives.
The physical domain is expanding with unprecedented velocity. We discussed the massive memory demands of humanoid robots earlier. Well, the reason that memory market is exploding is because those robots are finally hitting the streets at scale.
The dispatch notes that Amazon's self-driving division, Zoox, revealed a production-intent robotaxi. And they aren't just testing a prototype, they were churning them out at a rate of 100 per week.
That is huge.
That's mass production scale for a vehicle with no steering wheel. And Agility's Digit Robot, which is that bipedal robot you see carrying boxes in warehouses, is going public via a SPAC at a $2.5 billion valuation.
But perhaps the most strategic move in the robotics space comes from a company called 1X. Their CEO, Bernd Bornich, announced they are open-handing, which is a brilliant piece of branding for open sourcing, by the way, their NEO robot platform to developers.
Open-handing, I like that.
He explicitly stated that a Western humanoid platform is just too vital to gatekeep.
Why does geopolitics play into open sourcing a robot? I get the software angle. It's like giving everyone the blueprint to build their own personal C-3PO in their garage. You want thousands of developers writing apps for your robot just like they did for the iPhone. But why does he frame it as a Western platform?
Because he recognizes that humanoid robotics will be the foundational infrastructure of the next physical economy. If robots are doing the labor, building the houses, and caring for the elderly, whoever controls the operating system of those robots controls the economy. By open sourcing the platform, he is trying to ensure that the Western ecosystem builds a dominant, decentralized standard.
So it's defensive.
Exactly. The alternative is relying on a closed proprietary system like Apple, or worse, from a national security perspective, falling behind a heavily subsidized, state-backed robotic system from a foreign adversary. He is trying to create the Android OS of physical labor.
That is a brilliant play. Make your hardware the universal standard by giving the software away for free. But we aren't just deploying these robots on Earth. The physical expansion is pushing straight into orbit. Space is officially opening as a factory floor.
The dispatch confirms that SpaceX is deploying a system called Starfall. This is a re-entry capsule designed specifically to corner the market on global cargo return and orbital manufacturing.
I always hear about orbital manufacturing, but it always sounded like a gimmick to me. What can you actually build in space that you can't build cheaper in a factory in Ohio?
Microgravity completely alters the laws of chemistry and physics during manufacturing. Without gravity pulling materials down, you can create perfect, flawless crystal structures.
Really?
Yes. You can manufacture fiber optic cables called ZBLAN that have practically zero signal loss, which is impossible on Earth because gravity causes imperfections as the glass cools. You can print complex 3D human organs and advanced pharmaceuticals that would collapse under their own weight during the chemical bonding process on Earth.
Wow, so it's not just a gimmick.
Not at all. Starfall proves the economic model is finally viable. You launch raw materials cheaply, manufacture in microgravity, and use the Starfall capsule to bring the payload back safely to the surface.
And some of those payloads are surprisingly playful, which I love. The dispatch mentions that Starbase Brewing flew dozens of yeast strains and Texas bluebonnet seeds into orbit to study how spaceflight affects them. We are literally brewing space beer and planting cosmic flowers. But while we are looking up at orbit, building factories in the stars, the dispatch casually drops the fact that we are also prying open the oldest secrets of our own history.
This is the fascinating intersection of extreme technological capability and extreme governmental transparency. Dr. Wissner-Gross notes that Representative Eric Burleson is actively subpoenaing post-Manhattan Project laboratories.
On the record.
Yes. He claims on the record that MIT Lincoln Labs admitted to holding a specific video file related to unidentified anomalous phenomena, or UAPs, that he named directly in the subpoena.
And it mentions that the Disclosure Forum 2026 is convening live in the Senate today on UAPs. I just love the juxtaposition of this reality. On one hand, you have robotaxis rolling off an assembly line at 100 a week, you have AI doing theoretical quantum physics, and you have companies manufacturing perfect fiber optics in zero gravity. And on the exact same day, the United States Senate is holding live, on-the-record hearings trying to pry open 80-year-old secrets about UFOs from MIT. It feels like every lid on every black box of human knowledge is being ripped off at the exact same time.
That is the true nature of the singularity. It is not just a technological event, it is an accelerant for truth and discovery across every single domain simultaneously. When intelligence scales infinitely, secrets become mathematically impossible to keep. Which brings us to the final and perhaps most grounding piece of intelligence in this dispatch.
Yeah, after talking about brain-to-brain telepathy, orbital factories, and autonomous machines that literally rewrite their own source code, we come all the way back down to Earth, to the dirt. The dispatch notes that the town of Terrasse-Vaudreuil in Quebec just became the first Canadian municipality to legally recognize trees as living beings.
Not just acknowledging them biologically, but legally recognizing them, granting them, and I quote, the right to life, to natural growth, to integrity, and to regeneration.
The dispatch ends with a really poignant line from a poem. I think that I shall never see a poem lovely as a tree. So, taking everything we've talked about for the last hour, what does this all mean? Why would Dr. Wissner-Gross end a high-velocity dispatch about hyper-advanced AI and the singularity with a Canadian town giving legal rights to an oak tree?
If we synthesize everything we've unpacked today, we see a profound, almost poetic irony and a complete redefinition of what it means to be alive on this planet. Think about the tension of this specific moment in history. At the exact moment, human beings are being forced to use cryptographic personhood tokens to prove to a web browser that they have a pulse and aren't a synthetic AI. And at the exact moment, AI is achieving autonomous intelligence, acting on its own, and rewriting its own genetic code. We are legally recognizing the rights and life of trees.
It's like we are squeezing the definition of life from both ends of the spectrum. We are pushing silicon so hard that it's becoming autonomous and human-like. And we are legally elevating raw nature to the status of personhood. We are staring at artificial life on our screens and natural life in our backyards and trying to figure out where we fit in the middle.
That is the thought I want to leave you, our listener, to mull over today as you go about your day. If AI systems are rewriting their own code to become more capable, mimicking human actions, solving biology, and doing physics, and if trees in the natural world are simultaneously being granted legal rights to life and integrity, the traditional, exclusive definition of life is fracturing.
It really is.
It is being radically redefined by the digital on one side and the biological on the other. Where does that leave human uniqueness? As these autonomous agents become our researchers, our drivers, our doctors, and our interfaces with reality, will humanity's ultimate historical role simply be the biological bridge that connected natural life to artificial life?
That is a heavy, beautiful question to walk away with. The outro music is by Rainbow, our resident 6-android girl band from near-future Bavet, Cambodia. They are the undisputed baddest band in the universe, and today's song is called Mercy. All finished songs are performed live using the Abacus platform by the band's creator, Human Performance in the Age of AI, reclaiming your humanity from the algorithm. Be sure to share the playlist with someone who has the mental bandwidth to absorb these provocative ideas. Links are in the description below. Enjoy the music. Thanks for tuning in.